Greetings to everyone! Today you will see a teardown video of Pioneer Minidisc player MJ-D508. I have finished filming it a while ago, but only recently had enough time to finish the editing. But before I begin, I'd like to remind you that you can subscribe to this channel so you don't miss new videos. So, Pioneer MJ-508. I understand that it's not the most advanced model of Minidisc player, but the reason why I've decided to tear it down is because I have never owned Minidisc player. I have always liked this format and I'm very curious how it works. As always, I will start with removing the top cover. It is fixed with 2 screws on the left hand side, 2 screws at the rear, and last 2 at the right hand side. This top cover feels a bit floppy, and it's no surprise as it's a very cheap player. You can see quite a standard layout of the inside components: power supply unit, mainboard, mini-disc mechanism and display PCB, which also works as a controller. Next, I will remove the rear panel. I need to disconnect the power lead first. As you can see, it's soldered directly to the power supply, so I have to cut it. Later I will solder it back, of course. Now I will undo 7 screws which are securing the rear panel itself. Oh, it appears that the power lead is not threaded through the rear panel. That's fine, I needed to cut it anyway. I will use my long nose pliers to release the gland and pull the cable out. When it's done, I can carry on and remove the front AC. Before I start, I have to disconnect the cables. Analog input volume control cable first, headphones next, and the ribbon data cable, which links main and display boards, last. Also, let's not forget the ground bus cables. Now I can unscrew 3 screws which are holding the front panel. 1 at the bottom of the unit and 2 more on each side. 2 plastic clips are released and front panel can be removed. Great, let's take a closer look at the front panel. I will remove the headphones board first. It is fixed with only 1 screw. Pioneer didn't even try to make this player a bit more rugged. It's understandable as this player is rather cheap. Next goes analog input volume control, which is fixed with 2 screws. And finally the display PCB itself. 6 screws are undone, plastic clips are released, and the board can be extracted. The most visible component on this board is the vacuum fluorescent indicator tube, of course. It is sitting on the front side of the board along with dozen micro switches, IR receiver and digital volume control knob. On the flip side of the board sits CMOS 8-bit single chip microcomputer. I have seen a similar chip inside the Sony XB930E CD player. Now I will move on and take apart everything that is left from the front panel, so that I could give all these parts a good clean with warm water and dishwashing fluid later. Great, now it's time to extract the power supply. I will remove the power button extension first, then I disconnect 2 ground bus cables, and then the ribbon cable which links power supply and the main board. Great! Now I can unscrew the transformer, which is fixed with 4 screws directly to the chassis, and then release these 2 plastic clips which are securing the board. Here we go, PSU board is now free. It's a very simple board which supplies main PCB with 2 unrectified circuits and 1 more linearly rectified circuit. Now I can work on the main PCB extraction. After ribbon data cable linking the main board and the core PCB is disconnected, I can start undoing the screws. all 4 of them. But the main PCB is still held by these 3 plastic clips. Great, finally I can extract the main PCB. The AK7712A chip made by AKM Semiconductor is playing the main role on this PCB. AK7712A is a digital sound processor with built-in high-performance 20-bit 2-channel analog to digital converter and 4-channel digital to analog converter. Alongside with DSP, you can see the static random access memory chip. And remaining chips are input selector, CMOS inverter, phase-locked loop integrated circuit, and the last 2 are buffers. On the other side of the board there is a JRC2100D dual operational amplifier for analog input, JRC4558DD dual operational amplifier for analog output, and BA15218 headphone amplifier. And of course you can see RCA connectors for analog input and output, single RCA for coaxial digital input, and last 2 are optical in and out Toslink connectors. This is it, I believe I've covered this PCB in detail. Now let's move on and extract the Minidisc mechanism assembly. It is fixed with 4 screws directly to the chassis, and as soon as these screws are removed, the mechanism can be extracted. This is probably the thinnest chassis I have ever came across with. It's clear that Pioneer tried to compensate that by adding these hexagon-shaped bumps. To take a closer look at the Minidisc mechanism itself, I have to remove the base. 4 screws are undone, and now these parts can be separated. To reduce the amount of unwanted vibrations affecting the Minidisc mechanism, these rubber dampers are used. Not the best solution ever, but it does the job. Great, now that most parts are removed and all that's left is the Minidisc mechanism itself, my next step would be to remove the core PCB. First I will disconnect the recording head cable, then the loading motor cable, and then using the tweezers with plastic tips I will disconnect the ribbon cable. This ribbon cable links core PCB with switch unit ASI, which provides power for sled and spindle motors and also has 3 control switches on board. Now I can undo 2 screws which are securing this PCB to the Minidisc mechanism. I can lift the PCB from its place, but I have to do it very carefully as there is one more ribbon cable still attached. Again, I will use tweezers with plastic tips to disconnect the ribbon cable which links core and pickup PCBs. Great, let's take a closer look at the core PCB. You can see 5 chips on this printed circuit board. The most crucial one is this sharp encoder/decoder plus digital servo chip. Half of megabyte dynamic random access memory sits just next to the sharp chip. This, largest by size, is a Pioneer Mecha Control chip. It reads data from control switches as well as sensors and sends directions to the motor driver chip, which is this Mitsubishi 5-channel actuator motor driver chip. And the last one is this square sharp RF signal processor/amplifier. One more chip worth pointing out is located on the flip side of the core PCB. This tiny chip is a driver for the recording head. Its location makes sense because reading head connector is right next to it. That's all what I can say about the core PCB. Now it's time to take apart what is left. Rubber belt and 2 gear wheels can be removed. Load-in motor also can be extracted. Securing bracket removed and servo base ASI can be extracted. Upper slider ASI goes next. As well as clamp spring, switch lever, under slider, and shutter ASI is the last part removed from the loading base. Finally, all the parts are stripped down and servo base ASI is fully exposed. Here you can see spindle and carriage motors. That's the carriage itself with the MD pickup and recording head on it. The core switch ASI is the only PCB here. With the help of my visualization, you can see the exact placement of Minidisc inside the mechanism. Just a few more things I wanted to show you before I finish. These are all electronic components of the Minidisc player. All 55 screws together with the mechanical components of the player. Also, I thought that it might be interesting to take a glimpse inside the player while it's operating. So I reassembled it enough to play the disc and kept the view unobstructed. Enjoy the sight! So this is it for this video. I hope that you enjoyed watching it. Don't forget to subscribe to my channel and I'll see you very soon. Goodbye!